Hello everyone, let's continue where we left this journey by updating some of the packages we installed a few months ago. So let's update Cinemachine. I will pause during the installation. Okay, Cinemachine is done. Let's continue with post-processing. That's done. The next will be Text Mesh Pro. And finally, we need to also update from the asset store the Photon version. So let's go to the asset store, Control F, Control 9. Once loaded, let's search for Boon 2. And let's select the free version. And click import. Now from here we need to unselect Photon Chat. We are not going to install or use Photon Chat. From the standard libraries, just make sure that you not select the demos. We don't want to pollute our project with demo code. Utility scripts, that should be it then. Click on import. Once imported, let's close the asset store and let's continue by creating a set of new context for Entitas. To create the new context, we need to go and click the Tools menu. Then we have Jenny, Preferences. And if you remember last time we created the standard context that comes with the package, which is game and input. If you want to remember what a context is like a group or a pool where all entities that belongs to this context, this pool, will be reused. So whenever we stop using one of these entities, it won't be deleted but will be reused. And therefore the performance hit in this type of projects. I will put a link to this page in the description for you to check out. It's a good place to read and understand what Entitas component system is and how it works. So let's go back to Unity, and from here let's start adding our new context. So we want to add game state, careful with the casing, game state, audio, GUI, settings, framework, network. Let's leave it like that for now. And click on generate. So behind the scenes, what is doing this compiler is generating code, wrapper code for us. So as you can see here in the generated path, we have a wrapper for each of the contexts that we just created. And that will make our life easier when we create new entities and components. So let's move on to the next step. The next step is to import custom fonts to use in the game. I will put also the link in the description how to download those. Let's close up Jenny. Let's go to the asset folder, right click, import, sorry, no new asset, but import package, custom package, and let's select our font assets, import, and it will create a subfolder called _lh as of Little Hunter. Inside this folder we have our fonts, and now we need to create the text mesh assets for those fonts. So let's go to Window, Text Mesh Pro, Font Asset Creator. Since this is the first time that we launch the Text Mesh Pro Font Asset Creator, will be prompt to import TMP Essentials. So click on that button and let it import the defaults. That is done. Close it up, and then let's select the first font and click on Generate Font Atlas. I will leave all the defaults as they are for now. Then hit Save, and the new asset will be saved in the same folder path as the font it is, which is okay for us. Do the same for the regular font. Generate Font Atlas, save, and the last one, Azuki, generate Font Atlas, and click on Save. Close the Font Atlas Asset Creator, and let's move on. Last time we were working on the Bootstrap Scene, which is going to be like our director, our orchestra director. So from this scene, persistent scene, we are going to be loading all the systems, and is the hub where all the systems will interconnect each other. So let's now try to revisit this scene and make some changes in order to prepare it for that purpose. Let's add a new game, empty game object. Let's call it pre-bootstrap. Let's add another empty game object, and let's call it scene. As a child of the scene game object, we will add a camera, and also we are going to add a canvas. We can safely delete the event system. We are not going to use it here. And as a child of the canvas, let's add a UI image, and let's call this one logo. Now let's revisit all the properties and in the inspector for these elements. Let's start with the camera. So since this is not going to be a 3D scene, we don't need to be perspective, so we can change it to orthographic. We don't need the skybox, so we can change it to solid color, and let's put a black color. And again, if you don't want, we can just change the clipping planes to 50 in the 4 settings. And at this level, we don't need audio listener, so we can remove this component. For the canvas, we want to change the screen space to camera. Select the camera and drag it into the render camera. We can leave the sorting layer to default in this case, we don't care. And the constant pixel size, we need to change it to scale with screen size. And let's change the width to 10880. Okay. That will be it. Next, for the logo image, we want to set the width and height to 124 and 1024, sorry, 1024. And we can uncheck recast target. Now let's import the placeholder for our logo. So in the _LH folder, let's create another folder, call it textures. Right click on it and import new asset. So I will go where I have most of my resources, and let's click on it to import it. From here we will need the texture type to change it to sprite, 2D and UI. We can uncheck generate physics, and let's click okay, so in the default max size, let's decrease it to 1024 and hit apply. We can go back now to the logo image and drag the sprite. Let's save the scene and let's move on. So what we need to add here, we have in the Bootstrap game object our script. We are going to modify that one. We need to create a pre-Bootstrap script and also another script for the scene. So let's do that now. Since these scripts are going to be mono behaviors, because they need to be in the components in the game objects, and only mono behaviors can be added as a component. We had this sources folder in the past, so let's create now another folder, and I will call it mono behaviors. You can call it script if you feel comfortable with that naming convention. Now that I am here in the source code folder, I also going to add a data folder. We will use it in a minute. I'm going to add another folder for extension methods. We have interfaces, mono behavior, services, systems, and components. Inside components, these are the two components we made the last episode. So here in this components folder, I will create another subfolder and call it network. So it will hold the network related components. Now, coming back to the mono behaviors, I said that we need a script for pre-bootstrap, so let's create it. And let Unity compiler do its work. Now let's add another one for the scene component. If I can type. And let's see where we put the Bootstrap script so we can put everything in the same place. It's outside, so let's move it inside our mono behaviors folder. Perfect. Now let's assign each script to each component. Pre-bootstrap, scene, splash scene. The next thing what we need to do is to create a scriptable object that would serve as our game settings data, like a database that we can refer to, and it will persist during the whole game. And we can put there things that we can then query in order for game designers to tweak and change in case they wanted to try other things during the gameplay. So let's click on our data folder that we created, and let's do right click, create, and I have here a scriptable object. This is not coming by default with Unity, but I will add in the description a link of the video on how to do this by your own. So let's create a scriptable object and let's call it GameSettingsData. Let Unity compile and let's open Visual Studio. Let's add a using statement for system, and in this create asset menu we can set what is going to be the file name when we create a new scriptable object. So let's change this one to assets. Remember this path, _lh data settings, and let's call new game settings. Then in the menu name let's add this into a little hunter data settings game. Then what we are going to hold here is, for a starter, a public string with our game version. Let's add a nice header, game settings. We are going to hold our build number, and we are going to create a class that will serve a class preset to start adding some configuration groups. Like for this case we are going to add a new one, public class, for our network preset. We need to mark this class as a serializable in order to be shown in the inspector. And here we are going to hold our public int max number of players. That's something that Photon needs. And also we are going to store our public string, the room scene name. Then of course we need to create a variable of this type of class. So public network preset, let's call it network config. And let's add also a nice header, multiplayer settings, and also let's add some space in between, space 2F. This is okay. Let's go back to Unity and let it compile. Okay, so you remember that we specified a explicit path to save the new game settings. So let's create it. To be honest, I'm not sure if Unity will create it for us, so let's just be proactive in this case. Data folder settings, and then if we are in the asset folder, we can right click, create. Now we have this little hunter menu item, data settings game, and there we have it. So let's rename it to default game settings, and then here we can add game version, let's say 1.0.0, build number 1, and then in network config we can add number of players 4, max number of players, and I'm going to call the room scene as Sandbox. For now. Okay, so now let's move on to the rest of the scripts here. Okay, so the first script that we are going to change is the pre-bootstrap. So let's open up in Visual Studio. And from here we want to create a reference or have a reference of the scene object we created. So let's add it a public game object splash scene. It actually don't need to be public, so we can just change it to private, but to see it on the inspector we need to add the serializable field, serialized field, and then let's call the awake method, and from here let's add another function, another method to actually do the job, which is private void bootstrap start. And here we are going to activate our splash scene, set active true, and then we are going to deactivate this game object. Set active false, and let's call in the awake this method. Easy. Okay, so let's go to the next one, Let's Unity compile. Click on the splash scene script to open up in Visual Studio, and here we want a reference, so serialized field private game object to our Bootstrap game object. We want a reference to our image logo. And let's add the using statement for the UI. We are going to need also using for system namespace, using for system diagnostics, using for Unity engine scene management, and our friend .twin tg twinning. Okay, so let's continue. We want to create a variable of type stopwatch. You will see why in a minute. So let's call it stopwatch. Another bool variable to hold a flag, which are if whether we are loading or not. Then we call the awake method, and from here we are going to set the logo image alpha to 0. So in order to avoid having to write a lot of code to get to the image itself, that's why we created the extension methods. So I will create here how it's going to be called. Set alpha 0f. Do not save yet, and let's go to create our first extension method. Switch back to Unity, and let's click on the extension method folder we created. Let's create a new script, and let's call it graphic extensions. Let it compile and open up in Visual Studio. So here we need to change the seal keyword for static, and then let's create a public static void set alpha. We need to pass this graphic to make it work. We need also, of course, the Unity UI namespace. And this is not going to be a mono behavior. Then we need to pass the parameter of the alpha that we want to change. So from here we can create a variable of color, retrieve the color from the graphic parameter, from the color, let's retrieve the alpha channel, misspell here, alpha, and then finally we change the color to the new color that we are creating. Okay. Save this up. Now we can switch back to the splash scene, and now it's not complaining about it. Okay. The next method is the start. So I will also add the next ones we need to be called here. So we need a private void on logo image fade out. And the next one will be a private void load scene data. Okay, so in the start method we are going to use a logo image do fade from the twin library. So the alpha will be 1f, 1 second duration, and when this completed we are going to call a delegate method where we are going to do some stuff here. So first of all we are going to start our stopwatch to start counting. Then we have our Bootstrap game object and we want to set active to true. Then we want to stop our watch game object, object. And what we are doing here is the game will be growing, so we are going to be adding a lot of systems to this Bootstrap game object, and it will be in charge to load everything when the game starts. So it will take time, and then we can measure the time it takes to load everything, basically. And we are going to use that difference, this time that is taking to load, for the delay to fade in and fade out our logo image. So the image will be stay visible during this activation. So let's create a flow delay, and let's do a mathf max 0f mathf min 2f minus stopwatch elapse milliseconds. And finally we do the logo image do fade to 0 alpha, 1 second to do it, and we set the delay to start whatever we get in the delay float. And when this complete, not that one but the uppercase on complete, we can call our onLogo fadeout method. Okay, fair enough. So what we want to do when the fade out completes, we want to call our load scene data, and the load scene data, what it's going to do is, if we are not loading, we set this loading flag to true, and finally scene manager on load scene async Bootstrap. I hate magic strings. Later on we are going to change this to something, a variable. Okay. Scene data. Let's go back to Unity, let it compile. Okay, so before I forgot, let's add our game objects into its corresponding slot. So Bootstrap, our logo image. So let's deactivate the scene object and also deactivate the bootstrapped game object. And in the pre-bootstrap we need a reference to our splash scene. And let's save. Now let's work on the bootstrap script. So in this script we are going to change a little bit some things. The first thing we need to do is create a variable to store our first scene that we are going to go to. So first scene name. We want to hold also a public variable as GameSettingsData that we created, also the scriptable object. Let's call it GameSettings. This object variable that we're creating locally here, we can move it to a larger scope. So private context. I'm going to rename also this one to try to stick to some sort of naming convention for these objects. So context. And also we want to hold the settings context. That we created with Jenny compiler. Settings context. We have our game systems here. What I'm going to do is just to rename it. Then I want to create a public static bool property and call it is quitting. Get private set and call the awake method. And here what we want to do with this flag property is to register ourselves to the application quitting event. So whenever the application is quitting, this will call or set our property, and then we can just query this property instead of having to call this application is quitting all the time. So is quitting equals true, and then we want to actually call a custom awake method. So let's create that one. Private void do awake. And let's call it over here. Okay. So in the do awake, which is the awake actually, we want to tell this script to not destroy itself. So let's call don't destroy on load. We pass ourselves this. And instead of calling this shared instance here, we can put it in the awake actually. So let's move it there. We want to do the same for the settings context. So we set from the context that we already have from the shared instance, we call context settings. So we have a copy of the context settings here. And another thing that I found very interesting, I'm going to just paste this piece of code from the other project, is about the Unity random system, which is basically that we want to create our own seed in order to make the game not predictable, not to always start with the same seed every time the game starts. So this is very interesting, I found. Okay, so next what we want to do is let's move this game systems, new game system as well into the awake. This is looking more cleaner now, and we want to load our settings file, our settings data file, into our context. So let's create a function, a method for that. Let's call it load settings. Let's put it maybe here, private void load settings, and this will be as easy as set settings context set game. Oh no, not yet, because I forgot that we need to create our components. So let's comment this out and let's create components for this game settings. Okay, so let's go back to Unity, and in the components folder we had our network folder. Let's create a new folder and call it settings, and inside the settings folder let's create a new Entitas component, and let's call it game settings component. Once compiled, let's open up in Visual Studio and let's make a little bit of changes here. So we don't want this component to belong to the game context. We want it to belong to the settings context. Settings, and also we want to be unique. We don't want more instances of this component flying around. And from here we say public game settings data, and we need to add a namespace, and we call it this variable value. You will see why in a minute. Once we create settings, any component, every time we create a component, we need to go back to Unity, let it compile, and then we need to go into the tools Genie and generate. Click generate or shift Ctrl G. That will create wrappers for this new component. So if we go back to generated and we go to the context settings folder for the context, we now have another folder, components, and our wrapper here. That will allow us, if we go back to the Visual Studio, in the Bootstrap class settings, we were working with, we have now in the context our boost wrapper in order to set game settings, and it will expect actually our variable that we have here at the same time of the same type. So these extension methods are all generated automatically using the Genie compiler, so it's very handy. So this is all the changes that we need to do at the script level. So let's save. Let me close everything for now, and let's Unity compile. And now what we want to do is, in the Bootstrap game object we have a couple of slots. So we need to add our game settings, which we have in the settings folder. So drag it up, and then our first scene name is going to be, for now I'm going to call it launcher. Later on this will change to, let's say, the title screen or something like that, where we have actually a better menu for the game to start with. But as you see now that we already add a reference or as naming for two scenes, launcher, and if you remember in the settings file we have also the sandbox. So let's create those two scenes. Create scene, launcher, create scene, sandbox. And before anything else, let's add it to the build settings. So we have Bootstrap, launcher, sandbox. Let's save. At this point we could test just the process to go from one scene to the other, for example. So let's do that. So as you can see, we are now still in the Bootstrap scene, but we have our systems, the don't destroy and load, our component here, the onload scene. We have some warnings here. But again, now we have our settings entity with our settings data object. We have our movement and look still working as it was before. And if I go to the look input, moving the mouse, it changes the values. So let's keep working on this. Okay, so let's review what's going on here. Let's go to the Bootstrap script. And what I think we are missing is, let's see, in the start method, yeah, of course, we are actually not loading the next scene at all. So let's do that now. So let's do the scene manager. Do we have Unity? No. Let's add the namespacing. Unity engine scene management. So scene manager, load scene as sync, first scene name, and let's load it additive. Okay, so that will fix the warning we had, about trying to unload the only scene in the editor. Okay, let's try it once more. And there we are. We are now in the launcher scene. Okay, and yet our components still working. But what we want to do now is to remove this entity that we created during our debug session in the first session of this series. So let's do that now. Let's stop editor. Let's go to our it was in the features, game settings, yes. Open up in Visual Studio, and yes, we have this create entity system. Then let's comment it out and just have it for reference there, but we only need now to create our input system systems. Okay, now that we have our Bootstrap scene working as expected, let's go now to our launch scene. Okay, so let's open the launcher scene, and here we also need to structure a little bit this hierarchy. So let's create an empty game object, call it scene. Let's create another game object and let's call it systems. Something like that. So in the scene we want to move our main camera as a child of the scene object. We can delete the directional light. This is going to be a 2D scene with the main menu. Later on we will convert this launcher scene into our title scene. So let's now create here in the scene a canvas. It will generate an event system for us. So let's move that one into the system game object, and let's drag the on top. So since we are using the new input system, the standalone input module is complaining about it. So let's just click here, replace with the input system UI module. Perfect. Let's save the scene and let's keep working here. So what we want to do is to add the standard Photon sample, like when you ask for the player name and then the button to connect. As simple as that. So for that we are going to, in the canvas, let's create, but first of all let's remove the skybox and put a solid color, and let's change the color to something like that. Let's add it to our presets. Again, we can change the perspective to orthographic and the far clip into 50. Alright. So back in the canvas, we want to add a section for our player name selection and another for a loading indicator when we are trying to, or the connection indicator when we are connecting to Photon. So let's start by adding an empty game object that will add a rect transform on it, and let's call this one player name selection. We need to change, I forgot scale with screen again, so 1920 by 1080. And in the player name selection we need to add a canvas renderer. And after that we can add our UI TextMesh Pro input field. Let's just remove the TMP input field, and let's do small changes here. So the width will be 500, the height will be 90. Then on the text object itself, let's select our text, our fonts. So let's select Amatic SC regular. If we expand the input field, we have text area, and then also we have a placeholder and the text. So in the placeholder it's already set our font asset, but let's change this one to player name. And let's increase the font size 75 maybe. We don't want it to be italic, and let's put it in the center. Yeah, something like that. For the actual text that we are going to type here, we don't want the Amatic font because this is only uppercase. So let's change it to Azuki and leave it blank. But if we try to, well, it's too small, so let's increase the size 75 as well in the middle, and enable wrapping. So if we change to something else, and we have also uppercase, right? Let me see, input field, we can also change the top settings to 1 to 4, a little bit up. And next that we have our input field, we can add our button. So again, UI TextMesh Pro button. Let's change the settings. So the width will be 500 again, and the height will be 90. So they are both almost the same. Then if we go to the text component, we can as well change here the font asset to Amatic, change the text to start, and increase the font size to 75. Yeah, that will be enough. And let's add a little header here as well. So in the same group, like a player name, let's add now a UI TextMesh Pro text. Let's change the Y position in this case to 295. Let's change the font as well, and the text we can type here, enter your player name. Let's change the size to let's say in this case 80. Center the text and disable the wrapping. Yeah. Now let's work on the loading image or the loading text when we are connecting to Photon. So from the canvas, let's create another element. In this case, we actually want another canvas, and let's call it, well, let's say loading. And from here we also want to add a canvas group. Okay. And finally we need to add two images, or sorry, one image and one text. So this image, we can rename it and call it background. We want to raycast and set the background to black. We want the anchor to stretch to the whole screen. And finally, we want to change the text to, let's say, loading text, and the text itself, let's put connecting. Let's change the font asset again, increase the size of the font and put it in the center and disable wrapping. Yeah, good enough. Save the scene, and what we want to do now is to this loading game object to disable it. So as soon as we connect and we start connecting to the Photon server, we are going to activate this game object and then go to the next scene when we had a successful connection to Photon server. So as you can imagine, we need a script to manage what we want to do here. But also in the event system, we need to set which is going to be the first selected game object in order to get a proper navigation. So let's just add the input field there. And in the systems game object, let's create a script for handling these connections systems. So let's go to the mono behaviors and let's create a new script, and let's call it launcher system. Let Unity compile, and this is going to be a fairly simple system, or not system, but a script that will launch or initialize our systems. But we need to think about what type of data we actually need for Entitas components to hold. So we need a component to hold the player name. We need a flag component to tell whether we are changing the player name. We also need a component data to validate whether we can connect or not. So we can go now into the components folder, then we have our network folder, and let's create another subfolder there, and let's call it launcher, so we know that this component belongs to this scene in particular scene. So from here let's add a few components. As we talk about, the first one is going to be our Entitas component player name component. The next one is going to be another component called should connect component let it compile. The next one is going to be Entitas component, a component that will hold data whether we are in the process of connecting, pending connection component. And the last one is going to be a component that will tell us if we successfully connected to Photon. So connection successful component. Okay, so let's start writing this up. So let's start with the player name component. Open Visual Studio. And this component we also want to be unique per game. And here we can store public string. Let's call it value. Why value? Because remember that when we query components, we would have player name dot value, something like that. Let's have maybe some comments here. This component stores the player name of the active player. And let's save it up. Let's go back to Unity, let it compile, and open up the should connect component. This one we don't need to store anything there, so this when we don't have anything, any properties, any variables in this component object, it will be treated as a flag type of component. So it's like it's a question: should we connect? We want here to change the context to network in this case, and to be unique as well. Let's add a comment. Should we try to connect to the game server? Save it up. Let's move to the next one. Pending connection component. Again, this is going to be a flag type of component, so network unique. Let's add a comment. Are we trying to connect to the game server? And the last one, same thing, the network context, unique component, and this is a flag component as well, so we can just add the comment. This is a flag whether the connection was successful. As you can see, as the time goes and we start creating components, this will grow bigger and bigger. So I still believe that it's better to have a class, a single file per component, that have just a monolith, huge component file with all the components in order to be maintainable in the future. Alrighty, so since we added these 4 components, remember that we need to launch Jenny to generate our wrapper classes. I don't always Visual Studio is brought up. Okie dokie. So now, since now we have our components that we can use in systems, let's create the systems that we are actually do the work of connecting to Photon, change the player name, validate the button connectivity. Okay, so for that, let's go to our systems folder and let's make here a subfolder as well. So let's create a new folder and call it launcher. And from here we want to create an Entitas initialize system. So we want to initialize the player name. And let's call it initialize player name system. It compiled, so let's open up. So here in this system, what we want to get from the scene is the TextMesh Pro input field. So let's add a using statement tm pro, and let's create a couple of variables. So we need a private read-only tmp input field, and let's call it input field. Also we want the private read-only game context to cache our game context here. And in the constructor, this is some sort of dependency injection. We can pass the tmp input field and initialize it like so. So input field is going to be the input field that we pass in the constructor, and our game context is coming from the context game. Remember that the player name component exists only in the game context. So the initialize method, this is called like the awake or the start in mono behavior, if you think of a comparison. So from here we want to do the input field and bind event on value change, add listener, and we need to create a method. Let's call it on view update, and let's create this method here. So private void on view update, and let's do a game context replace player name. You see the extension method, the two options that it gives me: remove player name, replace player name, set player name, add entity index, or well, we don't have in this case add player name, but we need to replace, which will be like an update. And we need here to pass the string that the event is requiring, string and let's call it a new name. And this initialize system is as simple as we can see it now. So let's add just a comment here. System that modifies the name of the player according to the input field. Fair enough. Let's move on to the next one. Let's Unity compile. The next system we are going to add is for the start button. So it's going to be also an initialize type of system. So let's create Entitas initialize system, and let's call it initialize start button system. Let's double click it to refresh Visual Studio, and here we also need a reference to Unity Engine UI for the button component. Unity Engine UI. Let's describe what this system will do. System that connects the connection button to the ECS system. Yeah, something like that. So here we want to cache private read-only the button itself. We want also to cache the network context. And in the constructor, we can pass the button reference and then assign it to our cache variable. So button equals button, and the network context equals context, and give me the network one from all the context. Then we have the initialize, which is going to execute in the awake or start, so we can here bind our event in the button on click, add listener, and let's call it on pressed. So we need to create a method for that one, private void on pressed. So when we click on the button, when we press the button, we want in the network context set our flag that should connect to Photon to true. So since it's a flag component, it's going to have this prefix like is should connect. If you don't like to have this type of prefix because it's reads like awkward, you could in the component itself add, let me show you, launcher should connect. There is a flag prefix that you can put to remove this is, or add your own like flag, something like that. So when you compile this one, instead of is, it will say like flag should connect. But I will leave it as it is. It's not bothering me to me. So where was it? Should connect component. Let's remove this one. Okay. So when we press the button, we set the flag to true that we can connect to Photon, but we need some sort of do the other way around. So in this case, we can add another system from Entitas, which is a cleanup system, and every time this system or the components that belongs to this system are discarded, this cleanup will be called. So in this public void cleanup, network context is should connect to false. Simple and fair enough. So let's move on to the next system. After Unity compiles. So the next system that we are going to create now is the system that will handle the showing, the loading or the connection text when we try to connect to when we are connecting to Photon servers. So let's create this. Since we are going to handling displaying objects, Entitas has a special type of system that is called reactive system. So let's create a connection UI system. Okay, so let's load it up. Okay, and again, this is coming from the templates that I provided in the first episode. One thing that I want to do now that I see this is to change a little bit the namespace. So even though we are going to be reusing this system later on, but when we have our title screen in place, we are going to make some changes. So let's all these systems, not the components, but the system initialize player. Let's launcher initialize start button. So they all belong to the same namespace. Save. And from here, from this reactive system, we want to be in the network context. So instead of game entity, we need a network entity. So let's change all game entities instances to network entity. And here we want network. All right. And we want to cache the network context, of course. We want to cache the canvas group that holds the loading image or the loading text. Loading screen, let's call it loading screen. And we need, of course, Unity engine. And I know that we are going to use also .wing. Alright, so in the constructor we need to pass our canvas group, feel free to use better naming conventions if you want. Context, so we need to, from the context, retrieve the network context, and the loading screen, we set it here as well, loading screen. Okay, so we have this concept of iCollector. This is kind of a list that will be querying or created by with entities that has a specific requirement. In this case, what we want to retrieve is the list of entities in the context. So we create a collector from the network context. In this case, it will be a network matcher. So all the entities in the network context that had a pending connection, you remember this component, and this component is added, was added or removed. So we want the list of entities from the network context that has or this pending connection component has been removed. For the filter, this is a secondary type of validation. In this case, we are going to just leave it as it is. We don't need to do any specific validation from the list of entities that we are receiving. And lastly, in the execute method, this is going to be executed or run in the update method. We actually want here to do the loading activation. So just for security purposes, if loading screen is null, we can just return. Otherwise, if network context is pending connection, so is we are trying to connect, we're still trying to connect, then we set the loading screen game object set active to true, and the loading screen, the canvas group, to fade. To 1F, 1 second, and we can add that, set this is out expo, for example. There we go. We don't need this system collection. Let's clean up a little bit. Let's add a comment. System.switch the connection UI according to the state of the game. Alrighty, let's go to the next one. Okay, so now we need the system that will actually react to the connection or execute the connection to Photon servers. So let's create Entitas reactive system, and let's call it connection system. Let's open up in Visual Studio. Let's make a change here in the namespace launcher, and we want here a using statement for the namespace of Photon, boom, and also Unity engine. Alright, so this system is the system that manage the initial connection and room creation. Okay, again we need to change the game entity to network entity. And let's make the changes in the other methods. And from here we want the network context. Alright, so here we want to cache a couple of things. Read only the network context. If I can type network context, the game context, we want also the settings context, and we need a callback to another system that we haven't created yet, that we will add in a little bit. So let's modify the constructor for the dependency injection. So from here we want to set our network context equals to the context network. We want to retrieve the game context, and we want the settings context, settings. Okay, then we need to add here some callbacks. To talk to the Photon components. Alright, for the collector, in this case we need to retrieve all the entities that could have this component should connect, this flag. So context create collector of network matcher, where they have should connect. Alright, in this case the second validations, yes, we're going to add it. In this case we need to make sure that the entity we are working with or receiving, entity from the network context, has the should connect entity component on it. If the entity that we receive does not have this component, then this fails and the whole system won't be executed. So for the actual execute method, remember this is happening the update of the mono behavior, so we need to check if the game context has player name, so that we actually type a player name in the input field. Then we can make if Photon network is connected. If you are already connected to Photon, then we can just Photon network join a random room for now. Otherwise, Photon network connect using settings. That means create a brand new connection. Afterwards, we can change the flag. Network context is pending connection to true. So depending of what happens here, we're telling that this flag is changing to true. So again, like we did in the button, we need some way to change the flag to false. So we are going to add the cleanup system. So I clean up system, and we need to implement its method. So public void cleanup, and let's do network context is pending connection to false. Now let's work on this call. Okay, so from the launcher scene we had these game object systems. So let's create a script that is going to inherit from the Photon monobehavior Photon callbacks, and then we can use that script in our callbacks in the connection system. Since this is going to be a monobehavior, let's put it in our monobehaviors folder. And actually, well, we already did it. We have the launcher system, so let's just drag it there, and let's edit in Visual Studio. The launcher system needs to inherit from Photon callbacks, so for that we need to add the namespace Photon boon and monobehavior Photon callbacks. Let's also change the namespace to launcher and add some more namespaces that we are going to use. So using system Unity Engine, we need Unity Engine UI for the reference to the canvas elements. We are going to use using TM Pro, text mesh, and of course using Entitas. Alright. So this is the purpose of this script is to work similarly to the Bootstrap, where we initialize server systems and game system as well. But in this case we need the callbacks from the Photon system in order to know whether we are connected to the server or not. So let's start by adding some cache fields. So serialize field, if I can type, private TM input field, and this is going to be the player name field, serialize field, private button, this is the start connect button, serialize field, private canvas group. So the loading screen is not actually a loading screen, but let's call it that way. Then we need to register some events, action, public event action on connect, connected to master. Public event action of type object, array of objects actually, on Photon random joint, random join failed. Public event action on join room. So this is the event that we're going to bind to the callbacks coming from the Photon mono behavior. Then we can actually create our system here, systems. This is coming from Entitas, a group of general systems. Then we have another group of systems that we're going to call server systems. These systems are going to be called only at server side. Private context, the list of all our context, and private bool server system initialized false by default. So in the awake method we want to do a critical call about Photon, which is to sync all the scenes. So this is the comment that comes from the documentation, and we need to do a Photon network automatically sync level to true. After that we can retrieve all the contents for the shared instance, and having our list of context populated, we can then go through systems and create a new feature, and let's call it launcher systems. Let's create the server system as a new feature as well. A feature is just a group of systems. Server systems, and from here we can start adding actually our systems. So systems dot add new initialize player name system. Do you remember that one? And we had a constructor where we pass the context and our input field. So in this case is player name field. It's starting all to make sense now. So systems dot add new initialize, not that one, start, what was it, initialize start button system. So we need to pass as well the context and the button, start connect button. We have then the systems add a new connection system, the one that we were working, connection system. In this case we pass the context, and we actually, here is where we pass ourself or this launcher system with the callbacks to Photon. So we are going to create this one now, so that we pass ourself. Let's go back to the connection system just to avoid having this error here. So let's copy the class and go to the constructor launcher system, and let's call it callback caller, and let's add a cache reference to it before we forgot. Callback caller, callback color. We're going to work continue with this in a little bit. So from here, if we go back to the launcher system, let's save. We need to add the other system we created, connection UI system, and this one is expecting, of course, the context list, context, and the canvas group that we are storing here. There we go. We still need to create a server system that will actually do the work of, after connecting to the Photon server, to change to the, or to load the next scene, scene, which is the sandbox. But we are going to do it afterwards. So from here, let's add a comment. Just don't forget to do server systems. So do the start here, and from here we want to initialize all the systems. So all this system that we added in the start event will call its own initialize method, each one of those. Then we have the update method, and in here we need to check if Photon network is master client. So if it's the master client, if the server systems are not initialized, so we initialize here the server systems. Server systems initialize. So with it we make sure that this will only run on the server side. Server system is initialize equals false, equals true, sorry. Again, if we are the master client, we need in the update method the server systems to run their execute method, and in the server systems the cleanup method. As you can see, this system, we don't have any system yet inside this group, let's say, but yet we can just start creating the core functionality and add those later on, and this won't create any exception or any error at all. So if we are not the master client, we run systems the execute method of all the other systems cleanup, and the cleanup method. Okay, now it's time to bind the Photon callbacks to our events that we created here. So let's do this by creating a region, probably, just to make it organized. So mono behavior boom callbacks. So public override on connect to master. Let's close the region. So on connected to master, we want to invoke our action on connected to master. If it's not null, invoke. This is the one that we created here. The next callback we want is the public override on join random on join random failed. So if since our action is expecting an array of objects, we need to create a temporary variable code. Let's call it code and message, new object, new array of object, and here we pass the return code and the message. And then we raise our event. So on Photon random join failed, if it's not null, meaning that someone is listening to it, we pass code and message, our array. And finally, the last event, the last on join run. So we do an override on join room, and we call our on join room invoke. Fair enough. We need to create our server systems, but now we can go back to the connection system itself and map or bind these actions from the callback. Okay. So the three actions that we need to bind, let's put it in the bottom. The first one, private void on connected to master. So Photon network join random room. The next one, private void on Photon random join fail. We are expecting an array of objects. And from here's where we actually create our room. So Photon network, create room. Let's call it Sandbox room, and let's do a new Photon real-time room options to pass just the defaults. And let's do initialize property here, so max players, and here we can pass the max number of players that we added to our game settings. And for that we do the settings context, game settings value will return the actual game settings data scriptable object, and from here we set the network config preset we made, and we query the max number of players. Of course, we are storing this as an integer, and this max player is expecting a byte, so let's just do a quick cast here, and that will fix this issue. And from here we need third parameter, so let's click null. And yeah, we need to remove this here. Alright. We have one left, so we have private void on join room, and from here we can do a network context is pending connection set to false, because we already are in the room or join the room. And we set the flag network context is connection successful to true, to let the other system that we are already connected. And let's do a debug log here, maybe debug log room join Photon network current room name. There we go. So now in the constructor we can bind the actions that we are sending from the launcher system to our methods that we just wrote in the bottom. So here we do a callback caller on connect to master plus equal on connect to master, callback caller on photon fail on photon random join fail, and lastly callback caller on join room, not that one, the event, on join room. There we go. We can remove now the to do. And let me see, yeah, I think it's everything we need to do here, the connection systems. Now let's work with the server system itself, the one that will execute after we connect to run or to go to the next scene. Okay, so before creating the last system, let's assign from the launcher script this object. So we have the player name field, which is expecting an input field. We have the connect button, and we have the canvas group. There we go. Let's save the scene, and let's go now to our systems folder, launcher, and create here our last reactive system, which is going to be named let's say loading lobby system, just to be consistent of what Photon called the stuff. Let's Unity compile and load the script. Again, let's change the namespace launcher. Let's add a nice comment that we can remember 3 months from now. System that reacts to successful connection to load the next scene. Only runs on the server. Okay, so of course we need Photon using Photon pon, and we need to again change the game entity to network entity. and the context we need to filter is network. There we go, no errors. And here we need to cache the cache private read-only network context, and we need to cache the settings context, and we assign those here: network context network, and settings context settings. From the collector, we want to retrieve only those entities that had the connection successful component on it. So let's do that. Context, create collector of network matcher, connection successful, added. In the filter validation, we want to make sure that the entity we are working with has the component as well, the connection component, the connection successful component, connection successful entity, and in the execute, remember this is going to be in the update, we want to do the actual scene switch. Photon network load level. So instead of magic string, the name of the level, we can use the one we stored in the settings file. So we do the same thing here, settings context. From the settings context, retrieve the game settings, then the data, the network config preset, and the room scene name. Done. So let's remove this system collection we are not using, and let's save and go back to Unity. Let it compile. Once compiled, let's go to the systems. We have the launcher systems, and here, now that we have our server system, we can add it here in our to-do that we brought. So let's do server systems, add new loading lobby system, this is how we call it, and we need to pass the context. So we have the loading system. If it's master client, it will be initialized and execute, and here is going to load the new scene. So let's go back to Unity, let it compile, and let's open up the Sandbox Scene and just make it a little bit pretty or meaningful when we reach it. Okay, so for now let's create an empty game object. Let's rename it to scene. Let's move the main camera and the directional light to it. For the time being, let's switch the skybox to solid color. Let's leave it blue, and let's add a text 3D object, text Max Pro, and let's change the text to Sandbox level, let's be consistent with our nice font, so let's change it, Amatic, and let's move in the Y a little bit, center the text. Yeah, good enough. So let's make sure that our scenes are on the build list. And let's go back to our Bootstrap scene. So if everything is okay, let's give it a try. Now we are in the launcher. Connecting, and voila, room join. And we still have our input system working as expected. Yep, perfect. On the next video we are going to create the player prefab and spawn our character in this sandbox level. So thank you for watching, and see you next week. Bye bye.